Welcome to episode 52 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today, we're diving into AI and energy, from smart grids to predictive maintenance.
That's right. Energy powers everything, and AI is changing how we produce, manage, and consume it.
Let's start by framing the landscape. The energy sector includes generation, transmission, distribution, and consumption. Traditionally, it was a one-way street. Power plants send energy to consumers.
But that model is changing fast. Renewables like wind and solar are popping up everywhere, sometimes in customers' backyards, making the flow of energy more complex.
Exactly. This complexity is where AI shines. It helps manage the grid stability, predict demand, and optimize energy usage.
To put it simply, think of the energy grid as a massive orchestra. AI is the conductor, making sure each instrument or energy source plays in harmony.
I like that analogy. At the core, AI and energy means data collection and analysis. Sensors across the grid generate vast streams of data: voltage, current, temperature, weather conditions, and more.
And this is real-time data, which is key because energy demand and supply fluctuate constantly. If you think about rush hour or a sunny afternoon powering your solar panels, these loads change minute by minute.
This leads us to smart grids, which integrate AI and digital communication to monitor and react to these changes instantly.
Yes. For example, utilities use AI algorithms to predict when demand will spike or renewable output will dip. That way, they can adjust quickly without wasting resources or risking blackouts.
Another cornerstone is predictive maintenance. Instead of fixing equipment after it fails, AI forecasts failures before they happen.
This is huge in power plants and transmission lines. Sensors detect subtle signs of wear and tear, like unusual vibrations or heat, and AI flags these early warning signs.
It's like giving machines a sixth sense, anticipating problems before they cause downtime.
And that saves millions. For example, a major utility company used AI-based predictive maintenance on their turbines. They caught potential faults weeks in advance, avoiding costly outages and repairs.
Now, let's touch on energy optimization. AI models can analyze historical consumption data and optimize pricing or energy distribution.
In retail, this translates to demand response programs. Customers get incentives to lower usage during peaks. Behind the scenes, AI is modeling the best times and amounts to reduce load.
This interaction between consumer behavior and grid management is one of the most exciting AI applications in energy.
Agreed. And there's growing interest in prosumer models, consumers who both use and produce energy, like with rooftop solar panels.
From a data perspective, that means bidirectional flow of information and power. AI algorithms balance consumption with local generation and storage.
One interesting case is how electric vehicles fit in. They can charge when demand is low or even send power back to the grid during peaks, all orchestrated by AI.
This adds a layer of complexity, but also opportunity for flexibility and resilience in the energy system.
But Jonas, it's not just about technology. AI adoption in energy also faces practical challenges: data quality, integration with legacy infrastructure, and regulatory hurdles.
Absolutely. Historical infrastructure wasn't designed for such high volumes of digital data, so retrofitting and interoperability are ongoing challenges.
And on the regulatory side, energy markets are heavily regulated, varying widely by country and region. That influences how AI solutions can be deployed.
Still, the long-term benefits are clear: better sustainability, reduced costs, and improved reliability.
Speaking of sustainability, AI plays a major role in integrating renewables, which are variable and winter-dependent.
Right. AI models weather forecasts, historical patterns, and grid conditions to predict solar and wind output accurately.
And in one project I worked on, an AI system helped a wind farm optimize its turbine positions dynamically. That boosted output by several percentage points, which matters a lot in energy.
Another fascinating use is anomaly detection. AI scans sensor data to spot irregularities like energy theft or equipment tampering.
That's a critical issue, especially in regions with weak grid enforcement. Using AI to catch theft saves utilities significant revenue.
To summarize, AI's role in energy spans prediction, optimization, maintenance, and security, all driven by continuous data streams.
And it's transforming energy from a static commodity into a dynamic, interactive system that's smarter, cleaner, and more efficient. So what's the key takeaway for our listeners?
I'd say understand that AI isn't just about fancy algorithms. It's about harnessing real-time data to make energy systems more adaptive and resilient.
Well put. And from my side, the future of energy depends on combining domain knowledge with AI-driven data insights to manage increasingly complex systems effectively.
Next time, we're shifting gears to agriculture, exploring how AI is transforming farming practices and food production.
It's a fascinating topic that reveals how data-driven decisions are reshaping yet another vital industry.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your comments or questions. You might even get featured in future episodes.
Until tomorrow, stay curious, stay data-driven.